Hello friends, we are still not employed by FAANG company, so let's not stop lead coding till we get there. Today we are going to do a very important lead code medium problem, word break. Let's understand the problem statement. So basically we are given a string s and we are also given a dictionary of string word dict, and we need to return true if s can be segmented by all the words that are given inside the word dict. So if we look at the example, suppose our s is lead code and the word dict we are given is uh, first set is lead and second set is code. We can clearly see that this lead code we can generate from whatever the values we are given in this dictionary, so we will return true in this case. And we are also mentioned that we can use the same word multiple times. So suppose if this problem was lead code code something like this, we would still return true because or whatever words are, we can still make it through this dictionary. But if we were given some wording like this, that lead code lee, so up until this point we have the words that we can make from this dictionary. The thing is, this lee, there is not a specific word given for that. The word we are given in the word dictionary is lead, so it does not match. So in that scenario we would return false, otherwise we would return true. Okay, let's try to understand that what would be the brute force approach. Suppose we are given s is equal to espn and the dictionary we are given is esp and n. So we can clearly see that all the words are present in the word dictionary, so the answer should be true. And in the brute force solution we are going to use a bottom up approach. So and in this video I'm going to show bottom up approach all the way, even for the optimal solution. So this can also be solved as a top down approach, so let me know if you want to make a separate video on that. And there is also one more thing to consider. Suppose we are given something like s is equal to null value or empty string, and in the word dictionary we are given some elements like a b blah blah blah. So this case we can clearly return as true. Why? Because this empty element will always be there, though it might not be showing. But the thing is, if there are no elements in our given string, we can always return true because the emptiness is also exists in this word dictionary. So we are going to use this logic, and let's see that how we can build our brute force. So we are doing bottom up, so we are starting from the lowest value and eventually we are going to make the whole world. So the first value we need to, so we are at the 0th position. The first value we need to make is simply the word break of a value e, and the word break of value e is very easy to calculate. We only need to check that whether the word break of empty string and the value e exist in this given word dictionary or not. So basically, and we know that if there is an empty string scenario, this will always be true because I just explained it to you how. So we only need to see that whether this e exists in this word dictionary or not. If this exists, we can clearly say that this is true, and we can denote the value of word break of e as true. Now the second decision we can make over here would be to see the word break of two elements, so e and s. And how can we determine the word break of e and s? Well, again, it's simple. So we need to we have two ways to determine that. Either we can do a word break of empty string, and we can check that whether this es value is present in this word dictionary or not, or we can do a word break of value e, because we know that this is always true. The word break of empty is always true, so we can do a word break of e, and we can check that whether the value s is present in this given word dictionary or not. And word break of e, we already know how to do it. For this word break of e, we need to do word break of empty, and we need to calculate the value of to see that whether this e is present or not. The third option over here we can have is and you guessed it correctly, the word break of three elements, so esp. And for this three elements we again have three more possibilities, so word break of empty string, and we need to check that whether esp, all these three exist in this scenario. or we need to check that whether the word break of this E and SP exist, and the word break of ES and P exist. And yeah, so these are the three ways we can determine that whether the word break of ESP exists. The next option we have is the final scenario, that whether the word break of ESPN exists or not. And to check that, we will have four possibilities. So first one is that we check the empty string and we check whether the ESPN, the whole word, is present in this word dictionary or not. Or we can check that whether the word break of E is present and SPN, these three values are present or not. Or we can check that word break of ES is present and we can check for PN. Or we can check word break of ESP and we can check the value N. So these would be the four cases where we need to calculate all of these, and for every single one of them. So even in order to calculate this word break of E, we will use this method. To calculate this word break of ES, we will calculate this whole method. And yeah, so this would be the brute force solution. Eventually we would find that whether we are able to make this ESPN or not, and whatever result we get, we just need to bring it upwards and we would be able to find the solution. So this solution works, but it works in a very horrible way, because at every single location we have two possibilities to make: whether we want to keep that element or not, and our decision tree keeps on growing and growing and growing. And though we will come to the correct solution, but it's gonna take us a lot of iterations to achieve that, because over here you can see that we only had these four elements that we need to consider. We generated such a big tree, and over here most of the values we did not even completed the whole sub iteration for them, because I would be running out of space. So the time complexity, as you have guessed correctly, for this approach is actually big O of 2 to the power n, because at every single location we are making two decisions, which is pretty bad. And why it is 2 to the power n? Because we are calculating everything at the same time. So see that, do we have a room where we can save whatever we have calculated before, and can we use it further down the road? Of course we can, because notice over here this word break of E, we are using it over here, but we have already calculated its value. So why do we need to calculate its value again over here? Same goes with this word break of ES. We have already calculated the value over here. So why are we repeating this whole process? There are a lot of repeated effort. This is repeated, this is repeated, this is repeated. We have already calculated all these values. So somehow if we just create a cache, we store that whatever the values we have calculated so far, and keep track of that cache, and whenever we need to encounter that whatever value we are calculating right now, we can simply check that whether that has already been calculated, and using that we can actually come up to a better solution. Since you guessed it correctly, that because we are using something that we have already calculated in past, we are keeping a track of it in some form, and we are using it further down in our next iterations. So basically we are using the most beautiful thing in the computer programming, the dynamic programming approach. In the dynamic programming, we are going to create a single array of size whatever the given input string is, and based on that particular array we will calculate all the values that have been calculated so far. And because this is a bottom up approach, we are going to start filling up array from the 0th position, and we will reach at the end, and in the end, after all the calculation, we will just simply return whatever the value we have calculated over here. So let's see that what would be the optimal solution. Suppose again we are considering the same example. S is equal to ESPN, and the word we are given is ESP and N. And now let's create a new data structure called DP of an array that is of size 4, and there would be 0, 1, 2, 3, 4. Now we know that this 0th position would always be true, And why it would be true? Because this indicates that for dp of size 0, which means that for string of size 0, uh, does it does the word dictionary contains this particular element or not. This is what this dp is representing, that at every single location, whether the value of that length of the character, is it present in this word dictionary or not. So dp of 0, we know that that's an empty string, and if it is an empty string, we can determine the value as true. So this would become our base case, and this is very important to identify in a dynamic programming problem, that we need to have a base case. And initially we would set up all the other values as false, and we will run our iteration. So let's see that what each of these values are going to represent. And you guessed it correctly, that this value represents a word break of 0. This represents the word break of 1. So in this case it would be the value e. This represents the word break of value es. This represents the word break of value esp, and this one represents the whole word, so word break of the value espn. And yeah, so at the end, whatever result we find over here, if we just return that, that would be our perfect solution. So example we are going to take is the same one that we have been discussing. So the s is espn, and the value of word is esp and n. And we know that our dynamic programming of value 0, this is our base case, that is true. So what we are going to do is, we are going to iterate over, starting from single element, we are going to keep on increasing the size of our element. Depending on the size of our element, we are going to fill up this dp array, and at the end we will just return the value. So initially we will calculate for just for value e. So dp of 1 would be calculating the word break for value e. So let's see that whether this value e is present in this word dictionary or not. So the value is present, so we can say that the dp of 1 is true. Okay, this is good. Now let's check for the second element. So for dp of e2, this would be calculating the word break for es. Now we know that we can break down this word break for es in two parts. Either we can do like an empty string, and we can check for this value es, or we can do the word break for the value e, and we can check for the value s in this given word dictionary. If we go for this one es is not present over here, so we are left with the second approach. In the second approach, we know that word break of e, which means this dp of 1. So dp of 1 is already true, so we can say that okay, this is true. Now we only need to check that whether this s is present or not. So s directly is not present in this word dictionary, which means that this condition is not satisfied, this condition is not satisfied. So we can say that the value for dp of 2 is actually false. So we will just mention it over here that this is false. Okay, let's try to calculate the dp of 3. So dp of 3 means word break of elements esp. Word break of esp means three things. First one is that we can directly calculate to see that if esp is present or not. This is not present, so this condition won't work. Second one is we can check that whether the word break of e is present and the word sp is present or not. And third we can check is whether that word break of es is true and the p is present. Now the thing is, we already know that this condition is not true, the esp is not present, which means we need to check these two conditions. Now let's check this bottom condition first. So word break of es, this word break of es is actually in the dynamic programming array, it's the second position. So dp of 2, we need, so dp of 2 and the value p. Now we know that dp of 2 is already false, which means that this condition will also be false. So we don't even need to calculate, and we don't even need to check for this element p in the word dictionary, because we know that since this dp of 2 is false, we can just ignore this case and let's focus on this one. So word break of e, which means that dp of 1, so dp of 1 is true. If dp of 1 is true, which means that at least this condition is true. Now we need to check that whether sp exists in the word dictionary or not, and sp also exists in the word dictionary, which means that dp of 3, we can consider this as true. Let me also put this one on this side. Now let's calculate the dp of 4, which means word break of espn. So again, this will have 4 conditions. Now I'm going to write this in a different manner. So we can also say that this is dp of 2 and pn, because dp of 2 represents this es, and we can also say this as dp of 3 and n. And yeah, these are the 4 conditions we need to check, and if any of them are true, we need to return true over here. So let's check the first one. Does espn exist in over here? No, it does not, so this is false. So wb of e is true, so at least one is true, but spn does not exist over here, which means this is also false. Now dp of 2, this is already false, which means we don't even need to calculate and check for this pn. Now the last one is dp of 3. dp of 3 is true, so this is good. Now we need to check whether n exists over here or not. So n exists over here, which means this is true. So we find one case that is true, so which means that over here we can mark this value as true. And remember that this given string, this is of length 4. So because this is of length 4, we simply need to return whatever value we find as dp of 4, and that is true. So in this scenario, we'll just return the answer as true, and that would be our solution. This is a very good solution, because notice that we are already calculating what we need so far. We are keeping track of it at every single position. Because we have calculated these values, we are able to use it effectively and come up to the result. Let's calculate the time complexity. So we are iterating over all the elements at least once, so that is an n. Then we are also creating substrings. So for every value n, there can be n minus 1 substrings, which means that we need to do additional n work. So the time complexity would be big O of n cube. So this is also pretty high time complexity, but if you compare it with 2 to the power of n, this is actually way lesser. Because this time complexity, that can still be calculated, and this is a polynomial time complexity. But the thing is, this one is exponential, and yeah, we need exponential salary but not exponential time complexity. So let's code up the solution. Okay, let's create a boolean array to store our cache, and we'll name it as dp. We'll assign its length to s.length plus 1, and we know the base case where dp of 0 would always be true. Also for this word dictionary, this is a list, so we are going to create a hash set that will store the strings, and we will store this word dictionary over there, so it becomes faster for us to access the word dictionary. We'll just name it word set. Now I think we are all set to start our loop, so we'll create the 2 loops. Notice we are starting our loop from I equal to 1, because we don't need to we already have the value for I equal to 0, and we are going to start the second loop from 0th position, and while j is less than I, because we only need to go up to ith point. Now inside the loop, first of all, we will check that whether the dynamic programming for the jth value exist or not, and this is what I already explained in the solution explanation, that if this is true, then only we check that whether the word set contains the substring. So we'll use a substring method, and we will provide the parameter as j and I, because j is less than I. And if this is true, basically we just need to assign the value of dp of I as true. And yeah, I think that's it, and we don't need to do anything. And at the end of the loop, we can simply return the value of our dp of s dot length. And yeah, also when we find this value dp of I is equal to true, which means that we can break out of this inner loop, because there won't be another pair that we need to calculate, because even at any moment if we find a single true, that's sufficient for us. So let's try to run this code. Okay, looks like our solution is working. Let's try to submit this. Yeah, our solution works. It is accepted by LeetCode, but notice that this solution is actually pretty slow. It is taking a lot of time, and it is not as fast as our other solutions. So there is one trick we can do is, rather than going from from j equal to 0 to I, we can actually go in reverse. So we can start the position of j equal to I minus 1, and we can see that whether j is greater than or equal to 0, and we will do j minus minus. That way we would be able to find this a little bit faster. So let's try to run the code first. Yeah, this works. Let's try to submit it and see the significant difference. Now our solution is much faster, and even if you see over here, previously this one was running in 13 milliseconds, and this one is now runs in 4 milliseconds. Basically we are just eliminating and breaking out of this inner loop faster. We are not doing anything special. So yeah, this is just something to keep in mind. And yeah, I hope you liked it, and I will be posting this code in the comments.